Hello everybody. So let's go quickly over what we did last time. So last time we downloaded the RTDE folder, and today we will be talking about the example, how to implement the first program. So in this folder that you unpacked, you will be able to find a folder called examples, and inside of it you will have a file called example control loop.py. This is the file I'm talking about, so let's just go over it. What is important to note is the following. If you want the program to run, you will need this file that you see right now, all the packages that we talked about beforehand, and also UR provides you with a file called rtde control loop.urp. This is a UR script that you should upload on your teaching pedant, meaning the tablet that's connected to the robot. And in order to operate the robot, you need to run both the programs in your Python script as well as your teaching pedant at the same time. So after you load the program on your teaching pedant, you are going to set the control to local, not remote. This is very important. And you are going to play the program. You are also going to play the program that you see in the Python. So let's analyze the Python code first. Over here you can see we import all the necessary packages from the folders that we downloaded as well. The robot host is a number, it's an IP number of your robot, which can be found if you go to the teaching pedant. In the right upper corner you will see 3 horizontal bars. You click on them and you can access settings. Then you go to system, network and IP address, and you are going to copy that IP address and type it over here. Robot port is the robot port through which you communicate with the robot. Config file name is the control loop configuration XML. This is the file that's also inside the examples folder. It's an XML file that has all the recipes of state and set point as well as a watchdog. As a reminder, the states are recipes which you can use to read values from the robot. So in my case, I need an access to actually TCP force, so I have to define it over here. I talked more about them in the first video, but this is the main purpose. And the set points are the values that we want to send to the robot. So if I have a list of 6 values, let's say 6 joint values, I need 6 registers to have access to in order to send them to the robot and to be able to change them and to operate the robot accordingly. So all of those are defined inside the control loop configuration.xml. Keep running. This is something that's going to be used later. For now, I will just comment it out. A logger, it's also something that allows you to log the if you have any errors, if the robot is succeeding with what it's doing, you can have a logging file for that. I have it commented out because I don't want to keep creating a new files every time I run the program. It really, as the time goes, really makes a lot of mess on your computer. But if it helps you later on to solve some issues, feel free to uncomment it and use it. Over here we have the configuration files. We basically reformat the states and set points and watchdogs from the control loop configuration.xml file to the more Python friendly way so that we can access those values. We also establish a connection. We check if the connection is being established. Those are things that you should not change. This is something that comes with the robot, and just keep it as it is. The same the controller version. Over here, setup recipes. This is something that you should not change as well. On the line 68, we see set point 1, set point 2. Those are lists with 6 values of a point in the Cartesian space to which we want to move our robot. If you're not familiar, the first 3 values are the position in the Cartesian space, x, y, z, and the last 3 values are the rotations, orientation in the axis angle representation. Those are not very intuitive to look at, but this is what it is, and there is a option to change them to the Euler angles and to other representations, but this is too advanced to go into as of first video. So we define some set point 1, set point 2, meaning points to which we want to get. As I mentioned beforehand, each list has 6 values, so we want to be able to send those 6 values to the robot. That's why we need to initialize 6 registers which will hold those values. 1 register per value. So we initialize them to 0. We also have a watchdog which is used, and you can see how is it being used in the URP file on the teaching pedant. Usually those kind of watchdogs are being used as flags in order to make sure that the Python code is running at the correct speed and that it's being synchronized with how the code in the UR script on the teaching pedant is running. Here, as I mentioned before, we have 6 registers, so that's why the value over here is 6, because we want to be able to change the list to the set point in order to be able to send it to the robot. Those are 2 functions that we will be using. Actually, the function that we will be using in this case is only list to set point, because we have a set point 1 and set point 2, which are 2 points given as a list, and we want to reformat them as set points. Later on we have started data synchronization. This is something that also should not be changed. So coming back over here, what will you change? Robot host if your IP address is different. Besides that, those points, if you want to move to different points, you can also change them over here. If you are going to use more registers to send values than just 6, then maybe you should define over here more registers. But you should initialize them to 0 the way that they are initialized with the program that came from UR. Here you don't change anything, and while keep running again, I commented it out, so I'm just going to do the following. This is our main control loop, so we run it constantly till the state is none, and then we break. So what does it do? State equals con.receive. This allows us to receive a state from the robot. Again, those states are defined in the XML file, so if you want to have an access to joint values and you did not define them in those recipes in XML file, you won't be able to access those. Therefore, in our case, let's see, we want to access TCP post, so I'm just going to copy over here state dot actual TCP post. This allows me to read the TCP post from the robot, which is both the position and the orientation of the robot. I don't need it for now, so I'm gonna delete it, but this is how the code works and how this function works. Here again, as I mentioned beforehand, that the watchdog is very often used as flag, as it is in this case. So we have a small program. Basically, we are going to send a set point 1. However, if a set point that was sent is set point 2, then we send set point 1. If it's not set point 1, if it's not set point 1, then we send set point 2. This is just a bit confusing way that the Python writes it. I mean, it's much shorter, but I hope that you understand what it says. Basically, if the last point to which we moved was point 1, then move to point 2. If the last point that we moved to was point 2, then move to point 1. So again, as I mentioned beforehand, let's just for the demonstration purposes, I don't run it this way, but just so you can visualize, we have set point 1, which we want to convert using the function list to set point, and so it takes as an input list the set points, which were defined at the beginning as the bunch of lines over here, and we send it to the robot. Then we have a thread in the robot that loops in the program and waits for us to read those register values. If we don't have a thread, then maybe using the flag we can achieve the same result. and the robot is going to move to this value. So at the end we are going to send a watchdog, and we are also going to pause sending the values and also disconnect. So this is pretty much how it works. I highly recommend that you go over this code, and especially the code on the UR script, and understand how those two programs are being synchronized such that one works when the other works as well. I think this is the main point at the beginning. It's hard to understand how to run the program in a way that one program waits for the other one to finish before a certain code is executed. This is why watchdogs are used. This is why flags are being used, meaning variables that are assigned to some register that basically tell us, okay, now we finished certain part of the code. Tell the computer that we finished so it can execute a certain part of the code, etc., etc. I hope this will help you. I know it's a bit confusing. If there are any questions, feel free to let me know.